Okay, um, let's talk a little bit more detail about caching and integration and how they tie together. So, when we talk about persistence in the framework, um, all services, microservices, all microservice libraries, components, right, um, that have their own um, data store, right? They can all define their own data store, and um, we also have a default data store, um, which can be set up per instance of Aegis. The what all objects have in common is a, a cache, and that cache is not just a local cache, but it can also be distributed, and we can have other Aegis servers, remote Aegis servers, participate in the distributed cache. That means that when we um, when we write to the cache, um, that events are generated and forwarded to those remote instances, which have subscribed, to certain you know events for certain models. Um, maybe just a subset, maybe all of them, and they they will record that that event contains the data, the update, and then they will store that, deserialize that um, uh, update, and then they will unmarshal it by downloading the governing code from wherever that code happens to reside, which is encoded in the data. And then what they have then is a live object um, in their cache. And so let's show how that actually can be used. So when defining federated data, one thing you do is in the model spec you define a relationship between the two objects, the two models. So here in the order model, in the order model specification, we've defined a relationship called customer, and we said it's related to the model with a name customer, and it has a foreign key of customer ID, and it's a many to one relationship. All right. When the framework sees this in the model spec, it will generate a method called customer on the order object, which when you call that method, you'll retrieve the associated customer, if there is one. Um, and let's just show that. So in the, as I mentioned, you can call, as mentioned elsewhere, you can call a port, either by its consuming event or um, and that's when you're doing configuration based service orchestration, for example. You can also call it from from through an API, uh, or you can call it directly from code, which is what's happening in this case. So in this case, we're looking, does has a customer ID been defined? Okay, then we should be able to retrieve the customer record. Okay, so what this means is that this customer object, um, you know, it happens to be local in our configuration, but it need not be. The customer could be remote, in which case we'd subscribe to uh, we'd subscribe to the customer distributed cache events, and therefore this customer would be available to us through the cache. Even if it's a cache miss, we would still go and build this customer object, and then therefore we can interact with the customer object in the same way. So whether it's local or remote, we can write this code, and this code is valid, regardless of how we've actually chosen to compose the objects. And there may be good reason that we don't have them co-located. But obviously you should be take into consideration, these kinds of usage, right? Relationships between components, if they are if they're tightly, if they're very cohesive, right, and they're tightly integrated, and make use of one another quite frequently, then it probably wouldn't make sense to have them be remote, right? Because this operation is much cheaper, especially in the event that there's a cache miss. This operation is much cheaper, just done purely through a memory, and then we're just simply calling this this object, which is already in the local cache. In any event, so we have the object, and we can call methods on the object. So we're going to call a decrypt method, which is, again, this is really a port on the customer object, and then we can retrieve the decrypted version of the object.